And here we go. Alright. So the plan is, I want to figure out yesterday problems, right? Where I can like I can't use negative numbers, right? I can use like minus as an operation, right? But I can use negative numbers. I want to solve that, and also hopefully I want to add. I'll have enough time to also add multiplication and division today, right? And I was thinking about how I can solve this first problem with minus, because like that means this should be valid, right? Or shouldn't be? And because this one is basically the same as this one, right? Will it allow to do it that way? How do I like interpret this one? Right? Like this one, wait. Because this one was way too much. Like plus, minus, minus, plus. Should I limit the like the amount of operation to only 2? What if I'll do it other way around, minus plus? It also like kinda valid, right? Because it's like plus 6. 8 is like plus 8 by default. So I guess like the best way right now is gonna be to add tests, right? I feel like that's a great time to add testing. So let's look for C asserts, right? There probably should be in std. Assert macro. Assert at h, yep. How do I wanna do that? CMake test, I guess. Test with CMake and ctest. Add test name, test name. Okay, this means I have to like write header for my current. Yeah, like. Okay, no, for now let's just write it here. Call it void. No, probably let's call it. How do I, what will it return? Probably int. No, it's probably const char. It should be possible, right? To return const char. I see no problem with that. String literal, or how is it called? Now, test. Function cannot return array type. Seriously? The fuck? Why? Why? Why it can't? Wait. Okay, then just let's return nothing. Let's return nothing. Assert. Okay, it works. File. So what do I want to do? I got evil, right? File here. I don't need this one anymore. 86. Should be here. Const char file equals 8 plus 6. Maybe I should like abandon this altogether, right? I just use tests. Like basically do everything on tests. Breakers are not allowed here. What do you mean? To declare an array? Place the brackets. Oh, yeah. I'm yeah. I'm just so used to go. Assert. How do we do that? So basically, we tokenize file, right? Then we build ASTs and we evil it. Can I like do everything in a single step? Tokenize. Okay, let's create another function. Call it. I don't know. What it will return? I guess int for now, right? Because we're doing only arithmetic for now. Int interpret. How do you write interpret? I have no idea. Interpret. I was pretty close, wasn't I? Oh, I wrote it correctly. No way. Okay, interpret. Source. No, actually it's const. Char source. The fuck? Wait. Return. No, for now I have to create tokens. Create. Then I can basically doing all of that. Dynamic array init. src. It can error, but I don't check it, by the way. Okay, I guess it's okay. This for now. Tokenize. Token. Tokens item. Expression. Answer. I don't need this one. And this one I can just immediately return. Steer root. Yeah, and I can like go here, right? Right? Can I? Do it that way. Yeah, I can. Pretty good. I also want to make it this one more dynamic, right? So I can like basically write tokens equals the dynamic array init. But error testing is gonna be not good, right? It's not gonna be pretty. Probably will not. I mean, at least I have no idea how to make it pretty, because like I can return only one value from the function, right? I can return structs, but it's like how I will not be able to decouple them, right? So I have like I'll have to save it as a struct, and I have to like extract the first values and second values. Kinda feels awkward. Interpret. Assert file. Interpret. 1 + 1 equals 2. Is that how you do it? Wait. How does assert work? Can I go to definition? Damn, if only I was understanding anything. Built-in expect, E, assert. Const char. Yes, I guess it's not how you how you do it, right? See, assert. No, it's actually how you do it. Okay. Okay, pretty good. And sum is not greater than 5. Huh? Oh, it's just like for comment? Wait, it's kind of weird. Okay. Let's go with 1 + 2 = 3. Actually, I would want to duplicate this one and add some spacing here. Here and there. Just like that. It's like 2 here, 3 here. Yep. It's gonna be 4 - 3. Actually 5. Actually no, 7. And I guess it's enough to run it. Oh, I can't. Right? It should be here. Test. How do I do it? Make, build, and run. Okay, it works, I guess. Let's create some faulty test to like check if it actually works. Equals 3. It does work. Nice. Let's add multiple operations, right? So like 1 + 2 + 3 = 6. And then like plus 3 minus 4 equals 2. Also, how does it look? Assertion fail. Okay, so I see exactly which assertion fails. It's pretty good. Pretty good. Yeah, so let's think. Let's create new tests for future cases. So I can get. Actually, I don't have like some important tests here. So if it's like just 1, it should be 1, right? And I also don't have double digits. 30 equals 30. 24 plus 32 equals what? 66 minus 2, 64. Okay, wait, what? Trying to evaluate null expression. Oh, wait, what? Oh, this one. Okay. So minus 1 should result in minus 1, right? Okay, this one is fair, like there is nothing I can say about this one. This one should be minus 4, which is also fair. Now let's think about something esoteric, like plus minus 3, right? What if it's like plus minus minus 3? Like, technically, is it... Can you evaluate something? Can C evaluate something like that, actually? Printf 3 plus 4. No, it's not gonna work because like plus plus is taken, right? Let's do it that way. Wait, it works? No way. Huh? This spacing is so like suspicious, like it's gonna do something which like is not what I expect, right? See, make. Wait, where is the answer? 2 warning generated. Trying to relate null expression. Answer is 7. Minus, plus, minus, plus. Okay, so you can do that in C. Interesting. Should I allow this in a language? I would say yeah. I'm actually not sure. Like, this one, it looks kind of cursed. Like you have to think like 3 minus plus minus plus. What does it mean? It doesn't mean like just plus, right? No, really. It means minus. Right? So like 3 minus 4 is minus 1. 3 minus plus 4 is still minus 1. 3 minus plus minus 4. Damn, it's so ridiculous to think about. Wait, it will lead to 7? Wait. Let's go from the very beginning, actually. 3 minus 4. Minus 1. 3 minus plus 4. Minus 1. 3 minus plus minus 4. It's 7. Why? Why it's 7? Wait. So minus 4 is 1. Yeah, it makes sense. And here we go like minus, plus. Should we go from the like backwards? Minus 4 plus. Fuck, it's so cursed. How do you even reason about that? I should probably forbid that. Okay, let's think about just like two operations. Plus minus, right? And minus plus. It's like they're both equal, right? They're both like just minus. It makes sense. So it's like if there are like both plus and minus in like in a streak, they are like related to just minus, right? And this plus is gonna be still minus. So cursed. I guess I won't allow more than one. Okay, plus 3. Yeah, I can reason about it that way, right? So like, yeah, this one is like the best one to reason. Will it work actually? Yeah, it does work. Yeah. So like, each number each number have optional sign. What if this one is absent? That means like this one is by default plus, right? Yeah. Okay. Let's work on it. Let's work from here. Minus plus. Still minus 4. Wait, what? Wait. Yeah, no, wait. Minus 2. No, wait, yeah. Minus 2. So it's more like that, right? Yeah. How do I do that? So, that means... Where are my tokens? I got number token, right? And this token should also have like sign. Value is integer, so like I can... Damn, I ran out of tea. I should think. I should parse it in that way, so like int already stores the value of the number, right? But how do I do that actually? So like here, is it like 7? First minus, right? Let's go here. So like 1 plus a is taken, right? No, we see the sign. What are we doing next? We're checking if current expression have sign. If it has, but if right now we're like assuming it's the next expression, right? But how do we understand it? Like, it's not the next expression. We check if b is there, right? It kind of makes sense, right? So if b is not there, that means this sign is like the part of the b. Wait, but I'm thinking like in terms of AST, right? That's not how it's gonna work. I should think about like in terms of tokens. How does tokenizer work right now? Where is it? Evil? Build? Tokenize. Hello, Ankatama. I see the next engineer, don't say that. Like, we are doing basic arithmetic, what are you even talking about? How are you doing? What I was doing actually? Yeah, I was looking for tokenizer. So right now, basically what I'm doing, I'm just like, I see plus, token type plus. Maybe it's good, actually maybe it's good. Right? Yeah, like, the point of tokenizer is to just like convert everything to tokens. It should not like find errors or like... Yeah, so it's okay that I'm thinking it in terms of AST, right? So let's go to build AST. Token type null, not handled. Let's quickly edit. Token type null. I guess exit. -1. Printf. Unreachable. Build AST. Okay, pretty good. Now, yeah, so I got plus. We check if it's not null. We just add it, right? No. If current expression type is null. Okay, so if we already have sign in the current expression, what are we doing? We have to create another branch, right? So if check if current.b is present, right? Be present. If not present, my bad. Then we go into current. Oh, I have to do it absolutely differently. Yeah, I have to do it differently. Wow, wait. How will I... Do I have to create another variable? Like I have to, in some way... Like I still don't have number, right? But I already have the sign. How do I like save it to the number which I still don't have, to not override it later? Because later I'll just override it. Where is it? Like right here. T equals value. Should I like do T multiply value? And here make it like equals -1? It's kinda weird, not gonna lie. It feels really weird. It's probably not gonna work that way. Because like, I'm so afraid, I'm really afraid that like it will just multiply by 0. I have to like, somehow say that the sign is minus. But I guess multiplication is like the only thing I can do. Okay, so multiply here. That means we also have to multiply here. That also means it should not be 0 by default. It should always be 1. Right? Expression value should always be 1. Expression current. How do we create new expression? Current. Is num. Is present. Current dot a equals 1. Current dot b equals 1. Just like that. Oh, my bad. Num. Current be present. Current.b. Current. Wait, let me think. Like, it's so hard to reason about. We have to check, right? There's another check. If b is not present. Okay, so we already got sign, and b is not present. We are taking current.b.num and multiply it by -1. But that's if current.expression type equals... My bad, actually, wait. Wait. Key type, my bad. I mean, it would probably work this way too, but key type equals token type minus. Then we multiply it. Other way around, we should not. So like I can simplify it to this. So if b is not present and token type is minus, we can just multiply b by -1. Now, okay, previous is current. We create a new current, and we have to like assign everything to 1. A is non-false. A is present, true. Yeah. Wait, my bad. Yeah, only b equals num. I guess it should work. Okay, what if it's plus? Like, what if we got like +1? I guess we just ignore it, right? So like, we already have sign. Oh, it should be else. No, it should, wait. There's error. You know how I'm gonna do? Like, I'm gonna do... Yeah, I'm going, like, if... delete this one. If B is present. And move everything inside. This one is better. Can you format it, please? Yeah, thank you. Now... if we already have sign, we check. If it's like, if we don't have present, that means it's like another sign in a row. And we check if it's a minus. Then we multiply current by -1. Which should make sense. Then we check if current B is present. Then we just assume that it's like a new expression. Guess pretty good, actually, not gonna lie. Right? So let's try to evaluate it. 6 sec, thank you. Let's comment this build. Okay, no 6f. Let's uncomment them one by one. -1. Divided by 6 sec. Let's think. So I assume we have correct tokens, right? Tokens are fine. Like the logic for tokenizer is so simple and no way it's flawed. I guess I kinda see. No, not actually. Like now A present and B present are false. Right, so like this doesn't matter. Then we go in here. Token len is gonna be like just -1, right? So it's gonna like be a token type minus. Yeah, we don't check for instance if like it's the first sign, right? Let's try third test. For some reason I feel like it should work. I hope. It doesn't. -2. And what is like the answer? Can you like just how you do it? D touch N. What is the answer? Oh, it won't show here. Yeah. 4. Fuck, that's bad. It absolutely doesn't work. Should I rewrite it altogether? I have to like think. Like it's a state machine, right? So like, is it really like I have to just like think in sequence? How do you check everything, right? So there is like, first of all, there's optional sign. Every time there's optional sign. I should so token plus minus. I feel like expression is wrong, like I have to rewrite it differently. Okay, we got a sign, plus or minus. We check if A is there. If it's not, what does it mean? That probably means it's assigned to the A, right? Yeah. So if current A present and it's not present, right? Actually, it's this one. But now it's A present. enum. So if a is not present, and token type equals minus, then we multiply a by -1. What was the test? 1 plus -3. No, that's like not the problem why it's failing, right? Because minus is 1 is positive number. It's like the b is -3. Yeah. Okay, let's think through it. Through this one. 1 plus -3. So we get 1. What are we doing? We got a number. A is not present, so what are we doing? We're saving this number to a. We're multiplying 1 by current number, which is like current number. A is now equals true. Oh wait, it can be kind of nasty, right? Because like a is doesn't like have to be a number. But like I reassign it here anyway, right? So it should not like this probably doesn't matter. It probably doesn't matter. Yeah, it probably doesn't matter. Where I was. Yeah, so we like 1. A is now true. A present true. Nice. Break. So we're going to the very beginning. Now we got plus. We're going here. If current is not present, A is not present, which is false. We're going here. If we expression type is no. Oh no, if expression type is already there, which one we skip? Okay, if it's minus, was it like minus? It was plus, right? Yeah, it was plus. So we just basically assign. So now we got expression with 1 plus, which is pretty good. Then we got minus. We go in here again. A is not present, false. Expression is already taken, true. Then I actually have to create variables for each boolean because it just would be so much easier to read. We got, yeah, we already have sign. Then b is not present, which is true. And token type equals minus, which is also true. B num equals -1. Yeah, and break here, right? Break. That's what I'm missing. Break. That's probably the problem. Is it? Oh, I broke the previous function. Wait. The previous test. Wait. No way. Okay, I fix it. One more move here. Okay, so I should not break here. Why didn't we mark it as primary and unary? Or did I miss it? What do you mean? Kinda confused. As primary or unary? No, I just can't get it. Also, like, I'm kinda confused about unary. Like, I know something that involves or acts upon a single element or component. Computer science, unary refers to something. The fuck? The unary plus? Oh. But it's like, it's gonna be complex, is it? Like, you mean like, have a sign, like, shows that, explicitly shows that A has a sign, right? Like, create another flag for that. But I feel like it should be possible without it, right? Like, values already int, so int have sign. Right, so I can just like store it in sign. And the expression is one where an operator acts on a single operand. Yeah, okay. So it's like this one, right? Where is it? -1, right? It's an unary, and 3 is primary. Or am I wrong? And I mean, we can like mark them, but integer like is already. No, let's think about it. Actually, you know what? I want to rewrite everything. I feel like it's gonna be better. Let's just like remove everything, right? Case. Token type. What are we doing? I would rather start with a plus, I guess. What am I doing? Case. Token type minus. Case. Token type number. Minus. Okay. So we can have like sign can be the first token. So if we got sign, how do we know it's like it's related to the number and not to the expression? If we already have sign, right, it's probably related to the number. And if we don't have a, it's related to the a. No, it's not gonna work because like it can be the very first, and we still will not have expression sign, and so it's not gonna be the like, yeah. Wow, why is it so difficult? If expression type null. Wait. Current. Expression type equals expression type null. Right? No, like, if A is absent, it's guaranteed that the sign relates to the A, right? It's like always, if A is absent. Right, so if like A is not present, this means I can do like, how do I do it? Current dot A dot num equals multiply equals -1. In my impl I use this if plus minus includes this current value and this current type equals operator. It's just it's okay. So if plus minus includes current value, wait, how do you? Huh? Wait, what? I don't get it. So we got like an array, and if current value includes plus minus, like, but like how you like get this value, right? So like, I mean, can I change tokenizer? Like, you mean I have to change like my tokenizer? How does it work, right? So like, if I got plus before number, it's like two tokens. It's like plus and number, the same like for minus and number. Is that the problem? Should I fix that? Well, actually, that's probably not good. Wait. Okay, so if like I meet minus, I check next number, right? The problem is like that would mean that as a tokenizer I'll just get two numbers in a sequence, which mean I don't know what was the intention to do with them, right? I'm not sure if it's a good idea. Like -10 should be tokenized minus and 10, not -10. And then it should like be built into a -10. Wiki compiler. I saw like a great image here, where it was. Yep. If net more, do it no. There are no negative numbers. Fuck. Let's ask Gemini actually. Which approach is better? Then how do I write it? I want to tokenize, evaluate, following string. So it's like -1 plus 2. Is it better to tokenize as -1? Actually, I should do it as a way -1 plus 2, or and then during st build combine minus and 1 into -1. Okay, this question, like, it's not pretty, but okay. I could form it better, but okay. I hope it will, like, just say me all trade-offs. Oh, I got. Wait, it searches Google. Why, don't search Google. Like, okay, if we got -1 plus 2, right? This means like I also have to like add plus to the numbers, right? So like I can't just treat minus as a part of the number. I also have to treat pluses, which means like I have to, like, it's gonna evaluate in like 1 and 2, just 1 and 2 without minus and plus. Do I have to always treat a sequence of numbers as like addition? Is that like how it works? Is it overwhelmingly better and most standard practice to tokenize as separate tokens, yeah, and handle the logic during AST build parsing. Here's detailed breakdown of why approach is superior. The core problem, ambiguity and context. The character minus is ambiguous. It can be an unary negation operator, yeah, a binary subtraction operator. A tokenizer or lexer is fundamentally context blind, yeah. Its job is to break a stream of characters into a stream of tokens based on the simple rules. Yeah, each sequence of digits. Yeah. So like I have to keep tokenizer as simple as possible. The character plus is a plus token. It doesn't understand the grammatical structure of the language. A parser, on the other hand, is designed specifically to understand grammatical context. It knows what kind of token is expected at any given point in the code. Tokenize. So the string -1 plus 2 becomes the token string minus number 1 plus number 2, yeah? And the string 5 minus 1 becomes, yep. Parsing AST build. The parser uses the token stream and its grammatical rules to build abstract syntax tree. This is where the context is applied. The parser can easily distinguish the two cases for the minus token. Case 1. Case 2. Wait, the parser starts expecting an expression. It sees minus tokens since there was no expression before it. The parser knows it must be a prefix unary operator. Yeah. Okay, so like let's stick to it. Let's stick to it. Don't modify tokenizer. So we go in here. If A is not present, it's always a very first value, right? Because like we're going from the very beginning. But it will break. It will break the moment I'll add multiplication, right? Because it means like I got tokens, then like I have to go through everything to find multiplication, right? Isn't it? Fuck! It's so cursed. Damn, can I like close it? Fuck! I leaked everything. Why when I press right click it opens chat? Damn. Okay. If I add multiplication and division, which has a higher priority. My brain is burning. It is like it's only in the beginning. There's a problem. Like it's just an arithmetic. It's like we got tokens, right? We have like to understand in which sequence should we evaluate them. In which sequence we should build AST, right? Like in this image. Right, Lewis? Like here, right? So it starts if... Okay, actually here it's pretty simple, I guess. Multiplication? Yeah, here, wait. No, it starts from division. So here it starts not from plus, but from division. How does it know? So there is like a priority order, right? So like, first there are plus and minus, then there are multiplication and division, and then there are parentheses, right? So I have to go like find parentheses, then I find multiplication division, then I find plus and minus, and from this I should build my AST, right? Like I feel just so I will not need to rewrite AST one more time. Let's immediately add multiplication and division. Token type asterisk. Yeah, asterisk. Because like I also will add pointers, so like it makes sense. Slash. Pretty good. Type multiply. Divide. Is it like with I divide, or it's like yeah, it's divide, right? No way, no way. I don't know how to write divide. Wait. Yeah. Division. Is it? But it's like not multiplication. Wait. It's not addition. It's plus. Oh, but expression type addition. Subtraction. I guess it makes more sense. What type of expression it is? It's an addition, right? Is it how you write subtraction? It's like subtraction, subtraction, yeah. Multiplication. Division. The fuck, wait, right. Okay. Now. Let's go here. Quickly add. I should probably just switch it, right? Switch. SRC. I. Wait, my bad. Case. Plus. Break. Yeah. Minus. Multiply. Divide. Asterisk. Damn, that's such a weird name. Why is it asterisk? Is it like aster and risk? Why is it called asterisk? Why is it not like star? I don't know. Slash. Yeah. Now. Okay, so now we need several flags, right? So we're going through everything. We evaluate all multiplications. Fuck, it's so difficult. Wait, that means I can't evaluate them one by one. Is it okay? Like that means I have to go through code several times. Through all the tokens. And I guess I just can't fix it, right? Because like, let's create some example. Wait, what am I doing? So if it's like 2 plus 2 multiplied by 2. Actually, let's do it plus 2 and then multiply by 2 one more time. So if I convert this one into expression, this one is like, I cannot... Can I? Insert this instead of b. Actually, I can, right? Yeah, what's the problem? Like, if I create expression 2 plus 2, and then I notice asterisk, I can just like modify that the b part of the expression is no longer the number, but now it's the new expression, right? Yeah, that should work. It should work. And then I can like just go in a single sequence without going several times. So I create new node as a child, not as a parent. Then the current is this one. Oh, it's gonna become complex really quickly. Fuck. Maybe recursion will solve it actually. Okay, let's assume we're still here. We're still on a plus, right? We created children. This one. But what if like we have also multiplication here? We have to create children for children, right? Child for child. What am I saying? 2 plus 2. This one is a child, right? And this one becomes a child of this one. So current goes down. It's like no longer the top of the tree. It's 100% recursion. No way like you can do it other way around. Okay, let's add parentheses. I just like I want to be sure that I can like basically parse everything without going several times, right? It should be possible. I should be able to like just go one by one. Let's create that way. So we're going here. We add them. We got new expression. Then we find asterisk. What are we doing? We are taking 2. We are going here. And then we find parentheses. Right, so this parenthesis is like another child. Fuck, it's so complex. Okay, we're going... It's another child. We're still being the children. The child of... Is there a way to like reason about it in an easier way? What if like I have another multiplication here? Right, just like that. So we create child b, which is like multiplication, this one. Then we got asterisk, we got parentheses, so it's like a new child, but we don't know the end, right? Because like it's forbidden for us to go through tokens twice, right? Like everything is a single sequence. So the b is an expression, just like 2 plus 2. And then we're going down. Yeah, it works. I don't need to go twice through tokens. It should work. It's just like a single recursion. So then like here, I just replace the b child with 2 and it's still like the part of this. Okay, it should work, right? It's really difficult to reason about, but it should work. Now I think how am I gonna implement it? I should probably create like, what's it called? Like methods for expression, for nodes. Like void expression at child? I'm not sure. Okay, I guess I have to like stare at this screen for long enough time and I'll understand it. Honestly, I feel like... Alright, like this case is so good. Like I want to add another multiplication here. It's so good. So we're creating 3 here. Right? So it's like a basic expression 2 plus 2. Where it's like a, b. Then we like replace b with this expression. Not really. Like we create. Let's not jump like way too forward. So like we create multiplication where a is 2. So like now like we transform this one from like 2 plus 2 to 2 plus expression where a is 2, expression type is multiplication, and b is none. Then we go in. We see parentheses. What does it mean? Fuck, that also mean it can be that way. Let's assume it's not. I feel like it should be not that hard to fix. So what are we doing then? We are create another expression, right? And this is b. We enter this expression, and then we like take in the first expression for in the parentheses. So it's like a equals a equals 2. Type addition. B equals 2. So then we go next. Then we see multiplication, so then we go back. We changed. Like, this going back and forward and back, it's like, it feels... I don't know how to, like, implement it. So we go back. We replace number with expression, where a is number. Okay, I already feel a method, right? I already feel a method. So like, it's gonna be... void for now. It's gonna be... expression? No, wait. I want to convert num to expression, right? Num to expression. Now this naming is so hilarious. Expression num to expression. It's like expression is a prefix, right? So like, so I know it's like the method for expression. Num to expression. What are we doing? We have to know like which number do we take. I feel it's probably always gonna be b, right? It's like it's never a because we like never go backwards. It's always b, so it doesn't matter. It's always b. Then what? If we know it's b, it's nothing else. I just need a node. Expression. Node. Probably I wanna name it b to expression. I'm not gonna lie. Node.b equal, wait. I have to create new expression. Right? Expr. Actually, it's gonna be new expr. Calloc 1 set of expression, yeah. Then what are we doing? New expression dot b. No, my bad. A equals. Actually, before that we have to do a is num equals true. New expression. A present equals true. And a equals node dot b. Yep. Now what are we doing after that? We're taking node. We're doing b is present is already true, so we like going to b is num, equals false. Note b, just b, dot expression equals new expression. Yeah, pretty good, pretty good, pretty good. Seems fine. So now we can convert b to expression. So like we got 2 plus 2. Now we see multiplication, right? So we immediately convert this 2 to expression. Oh, I have to also pass which kind of expression it is, right? Because we'll at this point we'll already know which expression it is. Should I? Probably yes, I guess. I guess yes. Expression type. Type. Oh, it's type is reserved, isn't it? No, it's type def reserved. Type is not. Node. Expression type equals type. Okay. So we go. We are going. We got 2 plus 2. It's a new expression. Then we got multiplication. But like, how is it related to this? So hilarious. Like, the problem was this one. But how am I solving this one? I just hope the solution to this will solve everything, right? That's what was the point. Yeah, I'm rewriting everything. And I'm just like taking into account this, so I will not have to rewrite it in a certain time. Then replace 2 with expression, where like a is 2, type is multiplication, and b is none. Then we go next. We got parentheses, which means we go next, right? No, wait. We had to create child. That means that child is guaranteed to be expression, right? It's complex. Can I just like, if it's parentheses, right? I can straight jump through them. Just go next immediately. And take the first expression. Is it possible? Yeah, it should be possible. Right, if it's parentheses, we just like go. Then, but what if there are errors? That's like, it's so many, wow. Okay, actually at this point I feel kinda drained. I just like, my capacity to think about it just like decreases every minute. I think like I have to like take a break from this. Right? And come back to it later, because I feel like it's like harder to reason about everything. So I guess that's it for the day. Tomorrow I will continue.